Hey, it's Mr. Luneski. We are starting with Unit 8 today. Here's Section 1, Pythagorean Theorem. Unit 8 is my personal favorite unit out of this whole class, geometry. So let's get started. Pythagorean Theorem, we're going to look at that and its converse. We actually have already learned Pythagorean Theorem. If you recall, what that's saying is basically the sums of the squares of the legs is equal to the square of the hypotenuse. And just as a reminder, the hypotenuse is the side that is opposite the 90-degree angle. So we always want to look for our 90-degree angle, find that hypotenuse. Keep in mind that this only works in right triangles. This entire unit is based on just all right triangles. So everything we're going to be doing deals with right triangles. So these two problems here are just kind of a little bit of review, stuff that we did on the very, very first day. Putting our answer in simplest radical form, that's kind of a newer thing that we've been doing. So before we start, we want to find what's the hypotenuse. Keep in mind when we do Pythagorean Theorem, we should put c squared first, and you'll see why in a sec. So hypotenuse is x, so when I do this problem, I get x squared equals 4 squared plus 7 squared. Keep in mind the order of the legs does not matter. You can do 7 squared plus 4 squared. You'll get the same thing. So this gives me x squared equals 49, whoops, not 49, 16, getting ahead of myself. 16 plus 49, which gives me x squared equals 65. And remember, we have to solve for x, not x squared. So to do that, I square root both sides. Here's where you should check, can I put this in simplest radical form? There are no perfect square factors of 65, so this one is actually in simplest radical form. The next one here, find our hypotenuse. Here's the hypotenuse. So when I set this one up, it's going to be 12 squared equals x squared plus 8 squared. 12 squared is 144. 8 squared, 64. When I subtract 64 from both sides, that gives me that x squared is equal to 80. Remember, we square root both sides. So x equals the square root of 80. But 80 can be simplified into the square root of 6 times the square root of 5. And this, or I'm sorry, 16, excuse me. And the square root of 16 is 4. So square root of 80 in simplest radical form is 4 square root of 5. Next problem is what we call an application problem. We're basically putting Pythagorean theorem to use in a word problem. It says a 15-foot ladder is placed against a building to reach a window that is 12 feet above the ground. How many feet away from the building is the bottom of the ladder? Please read these carefully and think realistically about when you're setting them up. A 15-foot ladder is placed against a building. So when I place a ladder against a building, it looks like this. So we're saying that this distance here from the ground, here's the ground, from the ground to the window is 12 feet. Get rid of that. And we're saying that the ladder is 15 feet. So this is 15 feet. The ground and the building hopefully meet at a 90-degree angle. Hopefully we don't have a leaning building. And now we want to know how many feet away from the building is the bottom of the ladder. So we basically are finding this distance right here. So in this case, the hypotenuse is the ladder. And then the other two sides are my legs. So, solving this out, we get x squared equals 81. Square root both sides, we get x squared equals, whoops, not x squared, sorry, just x. We get x equals 9. So we can say that it's 9 feet away from the base of the building. Down here is a chart of something called Pythagorean triples. These are kind of these four things here, this, and this, are very basic, well-known sides that create perfect right triangles, where the biggest number is the hypotenuse. And so something that we do as teachers is we take these Pythagorean triples and then we kind of apply like take these numbers times 2. And that gives us sort of problems to generate for you guys. So if you take a look here, which one did we just do? We just did 9, 12, 15. 9, 12, 15. So nothing that you really need to know, but just kind of a nice little Pythagorean theorem factoid for you. All right, something new here is called the converse to the Pythagorean theorem. Basically, if we just are given 3 side lengths and we want to know, is this a right triangle, or what can we classify this triangle as, we can check the Pythagorean theorem. So if we have c squared equals a squared plus b squared, then we can say that the triangle is right. However, if c squared, or the biggest number, the hypotenuse, is less than a squared plus b squared, then we can say the triangle is acute. And if c squared is greater than, is greater than a squared plus b squared, then we can say the triangle is obtuse. The important part here is that you always start with c. I had mentioned that at the beginning of the video. If you switch it around and put a squared plus b squared first, then these things kind of get confusing. So it's nice to associate c squared less than with acute, and greater than with obtuse. So always start with c. And keep in mind, c is just the biggest number. So here's a situation where I give you 3 numbers, and this may look sort of familiar. We've looked at problems like this back in Unit 6. I would give you 3 numbers and say, does the triangle exist? And we used to say, well, 5 plus 12, we would take the 2 smallest numbers and say it's 17, and it had to be bigger than the 3rd side for the triangle to exist. So we still have to check that, but now we can take it a step further and say, well, this particular triangle, or these 3 sides, make it acute, right, or obtuse. So 13 is the biggest side, and so now we kind of want to know, is it equal to, greater than, or less than 5 squared plus 12 squared? So I simplify this out. 5 squared plus 12 squared, that's 25 plus 144 equals 169. So 169 and 169, those equal each other. Therefore, I can say this is a right triangle. So I'd be able to use Pythagorean theorem here. Here, 14 is my biggest number, so I need to check. 10 plus 11, that's 21. Yep, triangle exists. So 14 is the biggest side, so 14 squared, question mark. Again, the question mark is just kind of like, is it greater than, less than, or equal to? We don't really know, so I just put a question mark there. 14 squared is 196. 10 squared plus 11 squared is equal to 221. So 196 is less than, and remember, less than symbol looks like the letter L, is less than, therefore we can say this thing is acute. Finally, this one here, we have decimals. Don't let that scare you, just go on as normal. So 12.3 is bigger than 12.2, therefore we can say the triangle exists. We can proceed with this. So now we would say 12.2 squared, question mark, 4.1 squared plus 8.2 squared. 12.2 squared is 148.84. And when I add 4.1 squared to 8.2 squared, I get 84.05. And so 148 is definitely greater than that. So therefore this thing is whoops, I can't spell, obtuse. All right, there are 3 problems at the bottom for you to try out on your own. That is all. Thank you for watching.